Chapter 3, we cover straight lines. This is my class worksheet or my note for Chapter 3. The first concept, rectangular coordinate system. In this chapter, we study straight lines in the rectangular coordinate system. And the reason we learn rectangular coordinate system is because that's where do we study straight lines. Rectangular coordinate system, RCS. Rectangular coordinate system consists of two scales. One is a horizontal scale or x-axis. We label the horizontal scale x, called the horizontal scale x-axis. X-axis is in fact a real number line. The center is 0, and the direction to the right is the positive direction. The direction to the left is the negative direction. As you can see, we have two arrowheads, means the x-axis extending to both directions indefinitely. So this is a real number line, knowing this is a real number line. To the right of 0, we have positive numbers. To the left of 0, we have negative numbers. As you can see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And continue. To the left side of 0, we have 91, 92, all the way to 90, and keep going, right? So x-axis, horizontal scale. And another scale is y-axis. We call the vertical scale y-axis. It is also a real number line. It's just we place this real number line vertically. So on the y-axis, the center 0, the origin 0 is overlapped with the origin of the x-axis. So they intersect at the 0. And above 0, those numbers are positive. Below 0, those numbers are negative. So if we look at the real number line, y-axis, bottom up, the number is getting bigger. Top down, the number is getting smaller. This direction is positive. Go up is positive, and this direction is negative, all the way to negative infinity. So vertical scale, y-axis is also a real number line. Okay, so we have 0 here, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, and so on, all the way to positive infinity. Below 0, we have 91, 92, 93, all the way to negative 10, continue, all the way to negative infinity. So they intersect, the two scales, x-axis and y-axis, intersect at their origins. So this is a 0, all right? So the two scales divide the whole plane. This here does not mean the aircraft plane. It means a two-dimensional space plane into four parts. And we have names for the 4 parts. The upper right corner is the quadrant 1. We have 4 quadrants. Upper right corner, those points, this region, to the right of the origin, above the origin, that region is called a quadrant 1. And we go counterclockwise. We have a quadrant 2, quadrant 3, and a quadrant 4. So we have 4 quadrants. Knowing the rectangular coordinate system is not just this big, okay? It's not just what you see this big. It does not have any boundary from any direction. It is the whole two-dimensional space, the whole plane. Again, the rectangular coordinate system does not have a boundary from any direction. As you can see, x-axis to the left, to the right, they go to infinity, right? The y-axis go up, go down, also go to infinity. So this surface, this two-dimensional space has no boundary. And the two scales divide the whole two-dimensional space into 4 quadrants, 1, 2, 3, 4, as I labeled them. Okay? And I have a question here. I have a question here. How many points do we have in this rectangular coordinate system? My question is, this is a rectangular coordinate system, all right? It represents a two-dimensional space. Two-dimensional space. My question is, how many points in the rectangular coordinate system in this two-dimensional space? You can write your answer in the chat. How many points do we have? Let's see your answer. There are, exactly, infinitely many, uncountably many points. Thank you, Sean. Exactly. Please do not only see there's one point in the middle. Actually, we have infinitely many, uncountably many points all over the place. Okay, the whole space has many, all over the place. It's not possible for us to count the number of points because the whole space is made up of infinitely many, uncountably many points, right? In fact, and each point in the two-dimensional space is determined by two coordinates. In other words, it takes two numbers, two values, to determine the location of a point because it's two-dimensional space, right? That makes sense. It takes two values to locate a point in the two-dimensional space in the rectangular coordinate system. In fact, we have this one-to-one correspondence relationship. I want you to write it down, okay? What is a one-to-one correspondence relationship? The one-to-one correspondence relationship exists between any point in the rectangular coordinate system and any ordered number pair x, y. Both x and y are real numbers. That's my notation. I don't have to write this. I can just write the words. X, y are real numbers. Could be any real number. This is called ordered number pair. X, y with a parenthesis to frame them. This is called an ordered number pair. Okay? So the ordered number pair is a concept in algebra. Points is a concept in geometry. So there is a one-to-one correspondence between the two things. Actually, is telling us the two things are the same in essence, but in two different forms. Points in the rectangular coordinate system is the geometric significance of the ordered number pairs. The other direction, ordered number pairs are the algebraic expression for points in the rectangular coordinate system. They are the same thing in two different formats. Because they have this one-to-one correspondence relationship. What does that mean? It means for any point in the rectangular coordinate system, there's only unique ordered number pair correspond to it. Vice versa, for any ordered number pair, there's only exactly one point in a rectangular coordinate system make a pair with it. All right. Let me give you an example, then you can understand what is a one-to-one correspondence. Let's say all of us, we have a social security numbers, right? We can make a set. In set, we have our names, okay? Our names. In this set, the set on the right, we have our social security numbers. Then there is a one-to-one correspondence relationship between the two sets, because for each single of us, there's only one social security number in this set correspond to us, right? Correspond to the person. Vice versa, for any social security number in this set, there's only one person in a class make a pair with it. Yeah, nobody has two social security numbers. They're not supposed to. And for any one social security number, there's supposed to be only one person make a pair with it, right? Yeah, sometimes in a sense or in certain circumstances, the social security number represents the person, right? And the person is the social security number. So they are the same thing in essence. They represent the same thing in two different formats. I hope you understand what I'm talking about here. So for us, is what an important thing is, if I give you an order number pair, yeah, for example, the first example here, yeah, if I give you an order number pair, you know how to plot the point corresponding to that given order number pair. And another thing is, if I give you a point, like this question, if I give you a point in the rectangular coordinate system, you know how to find the corresponding order number pair. In rectangular coordinate system, we define points with the order number pair. Okay, yeah, look at the order number pair. It has two values. The first value is called x coordinate. X coordinate. It describes the horizontal displacement of the point. And the second value is called a y coordinate. It describes the vertical displacement of the point compared with the origin. So once I show you the examples, you would understand right away what do the x coordinates and y coordinate help to locate a point. Okay, let's start it. The first point is negative 5, 3.5. Okay, the first point J. The first component, x coordinate, is negative 5. Second component, 3.5, is the y coordinate. All right, remember, first component is the x coordinate. It describes the horizontal displacement of the point. It is negative 5 means, horizontally speaking, the point is 5 units to the left of the origin. Yeah, we always compare with the origin, the point right in the middle, okay? Yeah, so to locate point J, we start from the origin, go to the left 5 units. Go to the left 5 units. So 1, 2, 3, 4. This should be 5. Yeah, I'm right now. I'm here right now, but not done yet. Okay. Vertically, it has the second component, 3.5, means vertically speaking, the point is 3.5 units above the origin. It is positive, because it is positive, so the point is above the origin. X coordinate is negative 5, so horizontally is to the left. If the x coordinate is positive, then the point is to the right of the origin. So start from the origin, we go to the left 5 units and then go up 3 and 3.5 units. Let's see, 3.5. This is a 2, this is a 3. This is in the middle of 3 and 4. So it's right here. So to the left 5 units and up, go up 3.5 units. And this point is our point J. Okay, this point is our point J. Let me double check. X coordinate is negative 5. So the point is 5 units to the left of the origin. Y coordinate is 3.5. So the point is 3.5 units above 3.5. Let me double check this one. This is 2. That is a 4. So this is a 3. Between 3 and 4, yeah, 3.5. So that's point J. All right, let's do one more. Let's do 6.5, 6,95 point L. 6,95. This time, L has x coordinate 6, y coordinate is 95. So the point L is 6 units to the right because it's positive, right? 6 units to the right of the origin, 5 units below the origin. So I start from the origin, I go to the right 6 units, and then go down 5 units. Go down 5 units. Start from the origin, go to the right 6 units, and go down 5 units. Where is it? Back, please. Let me double check. This is 94. This is 95. Yeah, correct. So this red point in quadrant 4 is point L. Okay, is point L. And now I'm going to find where is point M. The coordinates of point M is 0, 93. Yeah, it has a 0 in the two components. When the x coordinate is 0, that means what? Means horizontally, the point is not to the right of the origin, is not to the left of the origin either. So that means the point is going to be on the y-axis. Yeah, it's going to be on the y-axis. Think about the point is not to the right of the origin, it's not to the left of the origin. It has to be on the y-axis. And vertically, the point is 3 units below the origin. So this is what I do to find the point M. We know the x coordinate is 0, means the point is on the y-axis. Y value is 93, means the point is 3 units below the origin. This is 2, this is 4, this is 3. Okay? Yeah. So if the order number pair has x value 0, then the point is be on the vertical scale. One more. I want to do k. The coordinates for k is 7, 0. All right? Yeah, this time, this ordered pair has y value 0. Y value 0 means vertically is not above, because if the point is above the origin, the y value is supposed to be positive, right? If the point is not below the origin either, because if the point is below the origin, the y value is supposed to be negative. And for the order number pair k, the second component, the y coordinate is not positive, is not negative, is 0. That means it's not above or below the origin. It has to be on the x-axis, right? It's not above, it's not below. It has to be on the x-axis. And horizontally, x coordinate is 7. So this point is 7 units to the right of the origin, k. Knowing if we have an ordered pair, the second component is 0, then the point must be on the x-axis, all right? It must be on the x-axis. Yeah. What else? We have J, we have K, we have L, we have M. Where's N? N is 4, 3. So this point N is 4 units to the right, 3 units above. So we go start from the origin, and we go to the right 4, and then go up 3. This point, right? No, here. This point. This point. Go up 4, so go to the right 4, go up 3. So that is point N. Point N is in quadrant 1. The last one, 96, 6. Yeah, I have a question. Can you tell me which quadrant does point P belong to? For point P, the ordered number pair, x coordinate is negative, y coordinate is positive. Which quadrant does this point belong to? Perfect. Yeah, very good. Jacob's here. Remind me to mark your attendance later. Exactly. So in fact, you know, in quadrant 1, all the points, yeah, we have infinitely many, uncounted many points in quadrant 1. All those points have a positive coordinates and a positive y coordinate as well. Yeah, both x and y value are positive. For quadrant 2, x is negative, y is positive because it's to the left of the origin, above the origin. For quadrant 3, both x and y are negative. For quadrant 4, x is positive, y is negative. Okay, yeah, so you want to remember that. Points on the x-axis have a y value of 0. Points on the y-axis has x as 0. Okay, so I think you probably know those already. It's just I don't know if it's really hard for you to show me because you cannot share the screen. So the second example is do the opposite. Earlier the previous example, we are given ordered number pairs. We are locating the corresponding points. In this example, we are given points and we are finding the ordered number pair that define that point. And this time you should be able to help me to answer the question. All right, I'm going to ask you to help me. Point A. Point A is in quadrant 3. Help me out. What's the ordered number pair that defines point A? I think, yeah, this is the origin. By the way, origin is 0, 0, okay? You probably know that already. Yeah, the origin is 0, 0. Yeah, A is in quadrant 3. That means both x and y are negative. So negative 7, negative 1, I believe. Negative 7, negative 1. Positive 1? You want to look at the more closer? I think it's a negative 7. Hold on. 1, 2, 3, 4, 5, 6, 7. Yeah, negative 7, negative 1. Negative 7, negative 1. It's not negative 8. You would have to count. Yeah, don't make a, because the point is right between negative 8 and negative 6, right? It's negative 7. What about point B? Point B is also in quadrant 3. So many points in quadrant 3. And what's the coordinates of a point B? I would say it's negative 5, negative 3. Awesome. Thank you, Dakota. It's okay, Jacob. Yeah, negative 5, negative 3. Exactly. Thank you, Joe. Negative 5, negative 3. Help me always point E. Okay? Help me always point E. Point E is right here. Is below, right below the origin. Yeah, what's the coordinates for point E? 0, negative 2. Awesome. You guys great. Yeah. 0, negative 2. Yeah, thank you. Very good. Oops, let me just close this one. 0, negative 2. All right, very good. Yeah, the origin is 0, 0. Normally we use the O, capital letter O, to represent the origin, and its coordinate is 0, 0. All right. Let me see if I have any other. What if I give you one more point? Let's say this point. How do I label it? F, G. Let's say that's point G. Can you help me to find the coordinates for point G? 0, 9. Perfect. And if I give you this point, what's the coordinates of this point? A, B, C, D, E, F, G, H. Point H. Perfect. Yeah, be careful with the order of the coordinates. X first, Y after. Exactly. I think you guys are fine. I think you probably know this already from previous practice. The reason we have to cover rectangular coordinate system is because it is the environment. You know, we study a straight line. Okay, we can start our lecture now. After we have the rectangular coordinate system covered, we're going to study a type of new equation, okay? It's called a linear equations in two variables. Let me give you the definition. Linear equation in two variables. Write down the definition on your note. Any equation that can be written as this form, or form ax plus by equals c, where a, b, c are real numbers and a, b are not both zeros. Let me highlight this sentence because it's very important. Any equation that can be written in this form is a linear equation in two variables. Obviously, the two variables are x and y, right? The two variables are x and y. Because we're studying the linear equation in two variables in the x, y, o plane, the rectangular coordinate system. So we always use x and y as the two variables. X and y are the two variables in the equation. All other things are constants. A, B, C, they are constants. A is called a coefficient of x, okay? A is called the coefficient of x. B is called the coefficient of y. C is the constant term. Do you guys remember last chapter? I said very important, we know two basic type of terms, right? The first type is a number times a variable, and the second type is a constant. So in this equation, in a linear equation in two variables, we only have those two types of terms. And this is called the standard form. And this is called the standard form. The star, the formula, the star is the standard form of linear equation in two variables. All right. You're gonna remember the standard form. What does the standard form of a linear equation in two variables look like? The equation equal sign is right here. On the left side, we have two variable terms. One is in x, the other is in y. Okay, a times x plus b times y. A is called the coefficient of x. B is called the coefficient of y. On the right side of the equation, we have a constant. So in this equation, in a linear equation in two variables, we only have these two types of terms. You don't see any other more complicated terms. It is linear because when we have the variable appear, the exponent on the shoulder of the variable always be 1. That means you will not see x squared, y cubed, or x to the power of -1. When you see x or see y, they all just show up by themselves. That means the degree or exponent is 1. When the degree is 1, make it linear. Linear equation in two variables because it has two variables, x and y, right? Let me say the definition one more time before we go to see the example. Any equation that can be written in this form, this formula, the standard form of a linear equation in two variables is the center of this definition. Yeah, anything that can be written in this form is a linear equation in two variables. Okay? Yeah. Let's try to determine, use the definition to determine if the given equation a linear equation in two variables or not. Yeah. The best way to reinforce the concept we have just learned is to use it. Okay? You remember the definition? Yeah. We're going to use that to determine if the given equation below are linear equation in two variables or not. Let me remind you, anything which can be written in this form, this is called a standard form, okay? Yeah, anything which can be written in this form is a linear equation in two variables. Yeah, I'm repeatedly saying the concept, the name of the concept, linear equation in two variables, and you want to memorize, you want to remember the name as well. So here, A, B are not both zeros. Okay. All right, the first one. The equation is 3x plus 4y equals 9. Yeah, what do you think? Is this equation a linear equation in two variables? So obviously it is, right? Yeah, I bet you agree. Yes, yeah. And what's the coefficient of x? What is the value of a? A is the coefficient of x. What's the value of a? Isn't that 3? It is 3, right? Yeah, the coefficient of y is 4. Coefficient of y is 4. And the constant is 9, is on the right side. So value of c is 9 on the right side. Okay, so let's see the second equation. Is x minus y equals 0. Let's compare with the formula and help me out. Is this equation number 2 a linear equation in two variables or not? Is this equation a linear equation in two variables? Yeah. Amanda, would you like to tell me what's the coefficient of x or value of a? Yeah, what is a, what is b, what is c? X minus y equals 0. Yeah, you agree this is a linear equation in two variables. And would you like me to tell us what is a, what is b, what is c? And you can type or you can. Okay, yeah. A is 1, B is -1, C is 0. Awesome. Thank you, Belle. Very good. Yeah, perfect. Number 3. The given equation is x plus 2y equals -8. Yeah. Is this equation a linear equation in two variables? If yes, what's a, what's b, what's c? What is the value of a?
Which one are we on again?
We are on number 3. X plus 2y equals -8.
Would it be 1, 2, and then -8?
Awesome, exactly, yeah. All right, guys, listen up. Number 1, number 2, number 3, they're all linear equation in two variables, right? Okay, now is the turn of number 4. Question, is number 4 x equals 2 a linear equation in two variables? Is number 4, this equation, x equals 2, a linear equation in two variables in a rectangular coordinate system? Yeah, do not answer no. Yeah, correct answer is yes. Okay, let me show you, okay? This is a linear equation in two variables because we are able to write this equation in this form. Let me show you how. We can write this equation as 1 times x plus 0 times y equals 2. Do you agree? Then our a, yeah, let me write a formula right under ax plus by equals c, right? Yeah, then our a is 1, our b is 0. A and b are not both 0. One is 0, the other is non-zero, is totally fine. Okay, yeah, that's the reason I emphasize this condition is important. Coefficient of xa, coefficient of yb, they are not both zeros. Yeah, but one is 0, the other is not 0, that's totally fine, as long as they are not both 0. If they are both 0, we don't have nothing basically. So, but one is 0 is okay. In this case, x equals 2. Y, variable y does not show up. Yeah, it doesn't have a variable y. It is because the coefficient of y is 0. Yeah, when the coefficient of y is 0, you don't have it. You don't have the variable there because 0 times anything is 0, right? Yeah. Yeah, a is 1, b is 0, c is 2. So by the definition, x equals 2 is also a linear equation in two variables. I know it might sound weird because you don't see variable y. Yeah, again, you do not see variable y is because the coefficient of y is 0. But x equals 2 is also a linear equation in two variables in a rectangular coordinate system. I want to make sure everybody understand that. Yeah, Jamie said, yeah, oh, okay, yeah. Do we agree now? Even in the missing variable y, it is a linear equation in two variables. It's just the coefficient of y is 0. Yeah. All right. So then I believe you might be able to answer number 5. Question number 5, the equation is y equals -5. Yeah. Is this equation a linear equation in two variables? Again, anything which can be written in this form, yeah, I'm circling, use my mouse, the arrowhead, is a linear equation in two variables. Yeah, yeah, let me see. Yes, it is, right? Yeah. Awesome. Thank you, Amanda. This time A is 0, B is 1. Yeah, C is -5. Yeah. Perfect. Thank you, Amanda. Thank you, Joe and Jamie. Yeah, exactly. So you know, because similar with number 4, right? Yeah, this time the missing variable is x. It's because the coefficient of x is 0. So A is 0, B is 1, C is -5. A and B, as long as they are not both 0, it's fine. Yeah, all those equations, are linear equations in two variables, especially number 4 and number 5. Okay, let me box it. Tomorrow and on Wednesday when I see you, don't forget. This type of equations are also linear equations in two variables. They are missing one variable is because the coefficient of that missing variable is 0. Okay. Number 5. Question number 5. We are talking about the same 5 equations. Okay. Yeah, the same 5 equations. I'm using the same equations. But the requirement is different. In example 5, we are going to find at least 3 solutions for each equation and plot those points and then try to graph the equation. So the purpose or the goal of example 5 is to graph the equation. Okay. Yeah, how do we graph the equation? We try to find the solutions of the equation and then plot those solutions. Okay, so let's start it. Firstly, we need to figure out what is a solution of a linear equation in two variables. How do we define it? Since a linear equation in two variables has two variables, then the solution of the equation must have two values. So if we have an ordered number pair a comma b, and if we plug x equals a and y equals b into the equation, and we got a true statement. In other words, a comma b satisfies the equation, then we say this ordered number pair is a solution of the equation. All right? Yeah. Since the equation has two variables, if the equation has a solution, the solution must have two values. So the solutions of linear equation in two variables are ordered number pairs. The first component is x, the second component is y. Yeah. So I'm going to ask you to help me to determine if 0, 0 a solution, if 3, 0 a solution, if let me think. If 1, 3/2 is a solution, and also help me out if 0, 9/4 is solution. Yeah. So I give you 4 ordered pairs. I want you to help me to determine or identify which of them are solutions, which of them are not solutions. Here the equation is 3x plus 4y equals 9. Yeah, we want to determine which of them are solutions of the equation. Okay, let's try the first one. Let's try 0, 0. How do we try? How do we determine if 0, 0 is solution? We're going to plug x equals 0, y equals 0 into the equation. Okay, into the equation. We have 3x plus 4y equals 9. And we're going to plug it in. All right, x is 0, y is 0. What do we have? Do we have a true statement or a false statement? True statement or contradiction? The left side is going to be false, exactly. The left side is 0, right side is 9. Obviously, this is a contradiction, right? It means what? It means 0, 0. This ordered number pair does not satisfy the equation. It is not a solution, okay? It is not a solution of the equation. Yeah, let's try the second ordered pair, 3, 0. 3, 0. This time we plug in x equals 3, y equals 0. Okay, 3, 0. And then you tell me what do we have. Are we having a true or false statement? Perfect. Thank you, Amanda. Exactly. Very good. Thank you, Joe. Because 3 times 3 is 9. 9 plus 0 equals 9. 9 equals 9 is a true statement, right? Yeah. That means the ordered pair 3, 0 is a solution of the equation. We found one solution. Yeah, let's keep going. Next, we are going to see if 1, 3 halves a solution. So we are going to plug in x equals 1, y equals 3 halves. Yeah, x equals 1 here, y equals 3 halves here. Let's see what do we have on the left side. Is the left side equal to 9? 3 times 1 is 3. 4 times 1.5, 3 halves is 1.5, is 6, right? Do we have a true or false statement? Yeah, we have a true statement. 3 plus 6 is 9. Yeah, that means we found another pair. We found another solution. This is a solution as well. Yeah, one more. This time we are going to see if 0, 9 over 4, x equals 0, y equals 9 over 4, satisfy the equation. So we plug in x equals 0, y equals 9 over 4. Tell me, do we have a true or false statement? True, exactly. Yeah. 3 times 0 is 0. 4 times 4 over 9 is 9. 9 equals 9, right? Awesome. So we found the 3 solutions. Yeah. Question here. Do you think we can find more solutions? How many solutions do you think this equation has? Yeah, we found the 3. Do you think we can find more? How many solutions do you think this equation has? Yeah, we can find more. How many more? For example, I can let x equals 2, right? I can let x equals 2. If I let x equals 2, I would need y to be 3 over 4. Okay? Yeah. So 2 comma 3 over 4. If you plug in, you would know. You'll see it satisfy. Yeah. Or, if I let y be 2, I can let y be 2 as well. Then I would need x to be 1/3. Then this pair satisfies as well. Okay, I can let x be 1 over 2, yeah, or any other real numbers. Do you guys see that? If I let x be any real number, be a specific real number, then I can figure out the corresponding y value. And the x value, y value make a pair, and that pair would be a solution of the equation, right? Yeah, I can let x be any real number. Yeah, could be 0, could be positive, could be negative, could be fraction, could be decimal, could be rational or irrational. Or I can let y be any real number. And then I'll solve for the corresponding x. And the x value, y value make a pair, and that pair definitely satisfies the equation. So how many solutions do you think this equation has? How many solutions do you think it has? Many, exactly. Infinitely many, okay? Yeah. So here you want to write it down. Yeah, any linear equation in 2 variables, any linear equation in 2 variables have infinitely many or uncountably many solutions. All right? Yeah. Let's see those solutions. We got 3 of them. I'm going to plot the 3 solutions in a rectangular coordinate system. Let's see what do we have, okay? And 3, 0, 1, 2, 3 is right here. 1, 1.5, 1, so this is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 3 halves. So it's going to be around here, right? And then 0, 9 over 4. 9 divided by 4 is 2.25. Yeah, 2.25. So 0, 9, 2.25. So go up. So around here, right? Yeah. So do you see the 3 points? They are collinear. Do you see the 3 points? They are collinear. If they are not, because I didn't draw them very well, they are supposed to be collinear, okay? They are supposed to be collinear. Yeah. Remember, this equation has infinitely many solutions. All the solutions are collinear. All those pairs that satisfy the equation are collinear. That means they are on the same straight line. Okay, look at the straight line, the red straight line. It has many points on it, right? Yeah, those infinitely many points algebraically, they are ordered number pairs. Those ordered number pairs are solutions of the equation. The infinitely many solutions of the equation build up or give us this straight line. Am I clear about that? The equation has infinitely many solutions. Those solutions are ordered number pairs, right? And those ordered number pairs in a rectangular coordinate system are points, and those points are all collinear, and they are the points on this straight line. And this straight line is the graph of this linear equation in two variables. And the graph of this linear equation in two variables is a straight line. All right? Okay, let's continue. Let's talk about this one. And I want you to help me to find some solutions for this equation, okay? And this equation is easy to find a solution because x minus y equals 0. If we plus y to each side, we have x equals y. So that means an ordered number pair, if the ordered number pair has x value and y value equal to each other, then the ordered number pair satisfies the equation, okay? For example, 0, 0, 1, 1, -2, -2, 3, 3. Yeah, as long as the x value and the y value, they are equal to each other, that ordered number pair satisfy the equation because x minus y equals 0, right? Yeah, as long as the x value and the y value equal to each other, then the ordered pair satisfy the equation. The ordered pair is a solution. So you can find, obviously, we can find infinitely many, uncountably many solutions, right? You can even do fractions, half, half, or decimals, -0.9, -0.9. We can find many, infinitely many solutions. For this specific equation, all those solutions are ordered pairs whose x value and y value equal to each other, okay? Yeah, 1, 1 is a good example. So now we do the same thing. We are going to plot those points on the rectangular coordinate system, okay? This is y, this is x. 0, 0, 1, 1, -2, -2, 3, -3. Yeah, we can easily find more solutions. And if you plot all those solutions, you will see all those solutions in a rectangular coordinate system locate on the same straight line. And the straight line is the graph of the equation. Okay? Yeah, this straight line actually is pretty special. Yeah, why the straight line is special? Because it is the bisector of quadrant 1 and quadrant 3. Yeah, let me write it down. This equation actually is the bisector of quadrant 1 and quadrant 3. Yeah, this is a 45 degree. This is a 45 degree. It is the bisector of quadrant 1 and quadrant 3. This straight line is the graph of the equation, linear equation in two variables, x minus y equals 0. Okay? So the second time we see the graph of a linear equation in two variables is a straight line. Number 3, the equation is x plus 2y equals -8. Yeah, this time you help me to find some solutions for this equation, okay? How do we do that? I want to make x be 0. Let's see, if x equals 0, we want to come up with a solution for the equation, right? Yeah, I want the solution has x value 0. If x is 0, can you help me out to find the y value? Can you help me out for the y value? Perfect, exactly. So how do we get that done? X plus 2y equals -8. we make x be 0, right? Yeah, if we make x be 0, we have 0 plus 2y equals -8. And we solve this equation, divide by 2, we have y equals -4. So 0, -4 is a solution. Yeah, you can double check by plugging in. It satisfies the equation. It satisfies the equation. So 0, -4 is a solution. Perfect. And the second solution, this ordered pair, I want a y value be 0. Can you help me out? If y value is 0, then what's the value for x? X plus 2y equals -8. Yeah, y is 0. Y this time is 0. So we plug in y equals 0, we have x plus 2 times 0 equals -8. And that is x plus 0 equals -8. X is -8, right? You see that? Yeah, whenever we give x a value, we are able to find the corresponding y value, and we got a solution. Yeah. Similarly, if we give y a random value, and then solve for x, and we get a pair, and that pair is also a solution. Perfect, very good. And then one more. How about I let x this time be 2? Yeah. What if I want x be 2 this time? And what's the value of y? I want this pair to be a solution. And I want the x value to be 2. Then y has to be what value? You know. If we let x be 2, yeah, how do we figure it out? Which is plugging in, right? X equals 2, plugging x equals 2. 2 plus 2y equals -8. We move this 2 over. Are we solving a linear equation in one variable right now? Yeah, that's something we learned from chapter 2, right? You see all those chapters builds on itself. Yeah, mathematics builds on itself. Chapter 3 builds on chapter 2. And we have 2y equals -8 minus 2. That is -10 divided each side by 2. We have y equals -5. Right? 2 comma -5. Yeah, we found another solution. 2 comma -5. Awesome. I can keep going, to find many solutions. In fact, this equation, linear equation in two variables, x plus 2y equals -8, also have infinitely many solutions. Yeah, we found 3. I think that's enough. Let's graph it in the rectangular coordinate system. Let's plot the 3 solutions. Let's see. Do we have any pattern? It's x, that is y. 0, -4. 0, -4. 1, 2, 3, 4. 0, -4. This is 0, 0, -8. This is -4. This would be -8, twice of the distance. -8 is around here, okay? -8 is around here. And the 2, -5. 2 is here. This -5 should be here. Yeah. So if you draw those points very accurately, you would see that they are collinear, okay? Yeah, they are collinear again. If you have many solutions found and you plot them all, you see they are all collinear. They are on the same straight line. And this straight line is the graph of this linear equation in two variables. So the very third time, we see the graph of a linear equation in two variables is a straight line, right? And we see this here. This linear equation in two variables, its graph is a straight line. Here, this equation is a linear equation in two variables, its graph is a straight line. Here, this equation is a linear equation in two variables, its graph is straight line, right? Okay, let's continue. We have 2 more to go. And do you remember this equation is a linear equation in two variables as well in the rectangular coordinate system. Do you remember that? We do not see variable y is because the coefficient of y is 0. Yeah, let me go back to remind you. Do you remember that? We will agree, right? X equals 2 is a linear equation in two variables. Why does not appear? Why doesn't appear in the equation? Because the coefficient of y is 0, right? Okay. So with that said, let's see how do we find the solutions. Yeah. So the solutions of this equation also ordered pairs. And you know what? We can easily find many solutions of the equation. Many solutions. Many. Okay. So do you think I can let x be 0? Could I let x be 0? Could I let x be 3? Could I let x be negative 10? Or x has to be 2? In order to satisfy the equation x equals 2, x has to be 2. Okay? X has to be 2. Yeah, because the equation is x equals 2. Yeah, if you let x be other values, let's say 3, you will have false statement. You have a contradiction. So we can't do that. X has to be 2, right? Has to be 2. But what about y? X is 2. What about y? When you plug in y here, coefficient of y is 0. 0 times y is 0. So really doesn't matter what's the value of y. It's all satisfied, right? Y could be any real number. Yeah. Let's pick some convenient number like 0, -1, 3, 5, -7. You know, I'm just randomly give some numbers. Yeah. Yeah, y could be any number. As long as x is 2, the ordered pair would satisfy the equation, because it doesn't matter what's the y value. You plugging in 0 times y is 0, it's still 0, right? So y value could be any numbers. Yeah, exactly. Thank you, Joe. Exactly. Awesome. You see that. Okay, so we find 1, 2, 3, 4, 5 solutions. Let's plot them on the rectangular coordinate system. Let's see, do we have any pattern? So x or y plane. Oops. It's x. Okay, 2, 0. 2, 0. 1, 2. 2, -1. So to the right 2 units, go down 1 unit. 2, 3. To the right 2 units, go up 3 units. 2, 5. 2, -7. What do you see? Do you see those points are collinear again? They're collinear, right? This is a 2. This point is 2. So again, you see a linear equation in two variables. Its graph is a straight line. For number 4, this equation has no variable y. Yeah, variable y is absent because the coefficient is 0. And the straight line that corresponding to this equation is a vertical straight line. Is a vertical straight line, okay? Is a vertical straight line. Yeah, any linear equation in two variables, if the variable y is missing, if the coefficient of y is 0, then the equation corresponds to a vertical straight line. The graph of the equation is a vertical straight line. Okay, so that's the fourth time we see the fact. We see the pattern. A linear equation in two variables is a straight line, right? It's just this straight line is pretty special. It's vertical. Okay, last one. And you might remember this equation, y equals -5, is also a linear equation in two variables. Its missing variable x is because the coefficient of x is 0. Okay, help me out to find some solutions. Find some solutions for this equation. If you understand the problem question number 4, you would be able to find the solutions for number 5 very easily. In order to satisfy the equation y equals -5, the ordered pair whose y value has to be 95, right? No problem, because if y values other numbers, you know, y equals 95, this is the equation. If you let y be other numbers different from 95, you would have a contradiction. So the y value must be 95. And what about x value? Yeah, Joe would say any number, exactly. Same reason, right? Yeah, because the coefficient of x is 0, it really doesn't matter what x assume in the pairs. It will always satisfy because 0 times the number is 0. So we can randomly give x values. We can let it be 0, we can let it be 5 or -5 or 1 or -2, right? And just randomly pick those values. Yeah, so we can find many solutions. Yeah, in fact, we can find infinitely many solutions. Awesome, very good. Thank you, Jill. Graphing. First point, 0, 95. 1, 2, 3, 4, 5. 5, 95. 95, 95. 1, 95. 92, 95. Ooh, what do you see? Do you see a straight line again? Yes. And this time the line is horizontal. Horizontal. All right? Yeah. Y equals 95. This linear equation in two variables. It's missing variable x because the coefficient of x is 0. And that type of linear equation in two variables, their graphs are horizontal straight lines. All right? So now we are using inductive reasoning. We're using inductive reasoning. We have seen one time a linear equation in two variables, its graph is straight line. 2 times, 3 times, 4 times, 5 times. Yeah, is a fact. Okay, it is a fact. Any linear equation or the graph of a linear equation in two variables is a straight line. So let me write it down. The fact is the graph of a linear equation in two variables is a straight line. I'm going to ask you this sentence on Wednesday when I see you, okay? Yeah, I'll ask you, what's the graph of a linear equation in two variables? First, I ask you, what is a linear equation in two variables? You must thinking, what is a linear equation in two variables? Yeah, what does a linear equation in two variables look like? And what's its graph? The equation looks like this, okay? It can be written in this form. And the graph of this type of equation are straight lines. In fact, there's this one-to-one correspondence relationship I need you to write on your note, okay? Linear equation in two variables, a, b, not both 0, and the straight lines in a rectangular coordinate system. They have a one-to-one correspondence relationship as well. For any linear equation in two variables, there's a unique straight line corresponding to it. Vice versa, for any straight line in a rectangular coordinate system, there's exactly one corresponding linear equation in two variables. Make a pair with it. Yeah, those are two things. They represent the same thing in two different forms. Linear equation in two variables, the equation is the algebraic expression of straight lines. And straight lines are geometrical or graphical expression of linear equation in two variables. Yeah, one is in algebra. Yeah, the equation is in algebra. The straight lines in geometry. They, format-wise, they're different, but they actually, in essence, the same thing. Okay? All right. So through this example number 5, I believe you know how to find, how to determine if an ordered pair is solution, right? You're just plugging in. And also you should be able to know how to find the y value if you are given x value, such that the pair is a solution. Or you know how to find the x value if y is given to make that pair a solution of the equation. You should be able to do that now. And next, we're learning x-intercept and a y-intercept. Okay, x-intercept and a y-intercept. Definition. Let me write it down. The x-intercept of a linear equation in two variables or a straight line. Yeah, since they have this one-to-one correspondence relationship, sometimes we just call one with the other name. Yeah, so linear equation in two variables, when we see a linear equation in two variables, we know that's a straight line. It would say this is a straight line. When we look at a straight line, we can say that is a linear equation in two variables. Yeah. So the x-intercept of a straight line is the intersection, or is a point, or is the intersection of the line and the x-axis and the x-axis. X-axis is a horizontal scale, right? Yeah. And y-intercept. Knowing the difference between x-intercept and x-coordinate and x-axis, they're all different. Y-intercept of a straight line is the intersection of the line and the y-axis. All right, that's the definition. Let me show you. Let's look at this equation. We have the equation graphed, right? Yeah. So where is the intersection of the line and x-axis? Yeah. Where is the intersection of the line and x-axis? Do you agree it is this big point? I make it very big, right? Yeah. Let me change the color. This black point. That point is where the straight line cut the x-axis. Intercept. How do you understand this sept? Sept, I think it means cutting, right? Intercept, yeah, cutting. So x-intercept refers to the point, the only point where the straight line cut the x-axis. That's the point. So that's the x-intercept. So x-intercept of this straight line, or this linear equation in two variables, is 3, 0. Yeah, the y value of x-intercept must be 0. And let's see this point, the blue point. That blue point is where the straight line cut the y-axis. Yeah, by the definition, it is the y-intercept. Y-intercept is 0, 9/4, right? Y-intercept of a linear equation in two variables must have x value equals 0. Very important, guys. X-intercept has a y value 0. Y-intercept has x value equals 0. All right? Because x-intercept is the intersection of the straight line and the y and the x-axis. Yeah, because is on the x-axis, the y value has to be 0. And then for y-intercept is the intersection of the straight line and the y-axis. So the x value has to be 0 because the point is on the y-axis. X value must be 0. And this straight line. Question. This straight line is the graph of the linear equation in two variables, x minus y equals 0. I mentioned this straight line is special, right? It is the bisector of quadrant 1 and quadrant 3. I have a question. What is the x-intercept and the y-intercept of this straight line? What's the x-intercept and the y-intercept of this straight line? X-intercept is the point where the straight line cut the x-axis. In other words, is the intersection of the straight line and x-axis. What is it? Yeah, you can type in the chat. No answer? What's the x-intercept? Hello? Am I still sharing? Yeah, I'm recording. I'm sharing. Oh, yeah. Okay, what is the x-intercept? Hmm. 0, 0, guys. 0, 0. The origin. Yeah, thank you, Joe. And what is the y-intercept? Y-intercept is the intersection of y-axis and the straight line, right? Yeah, it's also 0, 0. It's also 0, 0. And this straight line passing through, this straight line passes through the origin. That's why both x-intercept and y-intercept are the origin. It is okay to, the origin could be the x-intercept and the y-intercept, no problem. Very good. Thank you, Amanda. Thank you, Jill. All right, help me out with this number 3. This is the graph we draw for the linear equation in two variables, x plus 2y equals -8. Help me out. Identify the x-intercept and y-intercept. Let me repeat the definition. X-intercept is a point. You know, some teachers, even some textbook, they make this mistake and call the x-intercept, the y-intercept as one value. No, it's a pair. It has to have two values. Okay, it has to have two values because it's a point in the rectangular coordinate system. It need to have two values. So x-intercept is the intersection of the straight line with the x-axis. 98, 0, 0, 94. Thank you. Very good. Thank you, Jill. Exactly. X-intercept -8, 0. Y-intercept 0, -4. There we go. Perfect. Number 4. Same question, okay? Look at the straight line corresponding to the linear equation in two variables, x equals 2. Yeah, since the variable y is missing, yeah, the equation has a special looking graph. Yeah, it is still a straight line, but it's vertical. Yeah. Then what is the x-intercept? What is the y-intercept? Let me repeat the definition. X-intercept is the intersection of the straight line and the x-axis. Y-intercept is the intersection of the straight line with the y-axis. Yeah, they need to be points, okay, if they exist. 0, 2. You sure it's not 2, 0? You sure it's not 2, 0? Joe? Yeah, 2, 0. Yeah, x-intercept is 2, 0. That's why I say even some textbooks say call x-intercept is 2 is misleading. You have to make students write a whole pair because 2, 0 and 0, 2 they are so different, right? The order makes difference. Yeah, 2, 0. 2, 0 is the x-intercept, and y-intercept does not exist. DNE does not exist. Why? Because this straight line, vertical straight line, do not cut y-axis because they are parallel. They never cross, right? Yeah, so there's no intersection of those two straight lines. So the linear equation in two variables, x equals 2, has no y-intercept, does not exist. Very good. Yeah, very good. And last one, this horizontal straight line. What's its x-intercept? And what's its y-intercept? Again, x-intercept is the intersection of the line and the x-axis. Y-intercept is the intersection of the line with the y-axis. Yeah, x-axis, x-intercept does not exist. And what about y-intercept? 0, yeah. X-intercept does not exist. Yeah, 0, 95. Very good. And you must provide both values. 0, 95. If my student tell me 95, I would say wrong. You have to tell me 0, 95. Awesome. Very good. Yeah, as you can see, a horizontal straight line do not have x-intercepts, and vertical straight line do not have y-intercepts, right? And so that's the definition of x-intercept and y-intercept. We got this done already, right? So that's example 7. We already answered it. Yeah, don't forget. In general, if the equation is in the standard form, let me use this equation as example. Finding x-intercept and the y-intercept, very convenient. Yeah, because to find x-intercept, okay, all you need to do is to make y be 0. Look at here, guys. Make y be 0. Make y be 0. And this term disappear, right? Make y be 0. So this term disappear. It's 9, my bad. Yeah, that term disappear. And then 3x equals 9. Some of you might be able to quickly calculate x is 3, right? So 3, 0. Very convenient. Yeah. And to find a y-intercept if the equation is in a standard form. 3x plus 4y equals 9. You just need to make x be 0. Make x be 0. So this part disappear. This term disappear. And then now you have a 4y equals 9. Yeah, again, some of you may be able to quickly find the value of y. Divide each side by 4, right? Then y is 9 over 4. And that's the y-intercept. You see what I'm talking about? Yeah. So when the equation is in a standard form, finding x-intercept and y-intercept, very convenient. And graphing a linear equation in two variables in a standard form become very easy. Yeah, when you need to graph a linear equation in two variables, if the equation is given in a standard form, then finding x-intercept and y-intercept are pretty convenient. Then you can just use those 2 points to graph the straight line. In common sense, we all know 2 different points determine a straight line, right? You might also remember your teacher from previous school tells you to graph a straight line, 2 points are enough. 3 points make it perfect, right? Yeah. And normally I do 2 because 2 is sufficient. 2 different points make determine a straight line. And x-intercept is a point. Y-intercept is another point. And those 2 points are enough to graph the line. And finding the 2 points are so easy if the equation is in a standard form. Okay, so if you find the x-intercept, you just make this part disappear, right? And if you need to find a y-intercept, you just need to make this part disappear, right? Yeah, very convenient. Yeah, what I'm trying to say is, for example, this equation, x plus 2y equals -8, right? Let's do one more time. To find the x-intercept, we know x-intercept has a y value of 0, right? We make this part disappear. To find the x-intercept, make y equals 0, so that part disappear. You have x equals -8. Do you see that? X equals -8. You are looking at x equals -8 after you make y disappear, right? To find the y-intercept, you make this part disappear. You make x disappear. And you are looking at it right now, 2y, twice of y equals -8. Of course, y is -4, right? You can very quickly to find the y-intercept. Yeah, let me know, am I clear about what I'm trying to show you? Yeah, graphing a straight line, graphing a linear equation in two variables is very important. If the linear equation in two variables is given in a standard form, ax plus by equals c, then using the x-intercept and the y-intercept to graph the line is very convenient. Yeah, very convenient. And for the horizontal and the vertical, let me show you horizontal and vertical. So x equals 2 is horizontal or vertical? Let's see if you remember. Number 4, x equals 2 is horizontal or vertical? Guys, x equals 2, horizontal or vertical? Vertical. Yeah, x equals 2. X equals 2 is vertical. So how do we know it's vertical? So in a rectangular coordinate system, look at the x-axis. This x equals 0, this x equals 1, this x equals 2, right? At x equals 2, you draw a vertical line. Okay? And similarly, how do you graph y equals -5? Yeah. If you are missing x variable, the equation represents a horizontal straight line. You have to remember that. I show you why is horizontal, right? Because x value could be any numbers. Yeah, x value could be any numbers, but y value is fixed at 95. Yeah, y value is fixed at 95. X could be anything. So x could be positive all the way to positive infinity, could be negative all the way to negative infinity. So that gives us a horizontal line. So if you have y equals 95, you start from the origin, go down 5 units, and you draw a horizontal line. Okay, so that is about standard form, about the standard form. In this chapter, we are going to learn 3 different forms for linear equations in two variables. Earlier, we have the standard form, okay? Now we are going to start to learn the second form. It's called slope-intercept form. To get ready for that, we need to learn what is the slope first, all right? What is the slope? Definition of slope, slope formula. Slope is rise over run. Slope is rise over run. Slope of a straight line is a property of the straight line. It's like your eye color, you know, your personality, or not personality, it might be changed. Like your DNA. Yeah, like a slope is the part of DNA of the straight line. Okay, it's part of the straight line. It determines the steepness of the straight line. Also determine how does the straight line go from one point to the other point. Yeah. So passing this point, go this way, or go this way, or go that way, right? And simply put, slope is defined as rise over run. And if we consider this straight line, and we have 2 points A and B, we go from A to B, then this is a rise, right? And this is the run. You put the rise in the numerator, you put the run in the denominator, and you get a quotient. And that value is number, slope is a number. And the number is the slope of the straight line passing through A and B. Okay? Yeah, rise is the vertical change. Yeah, vertically is go from here to here. That is a rise. And the run is the horizontal change. From A to B, horizontally, it go from here to here. So horizontal change is this much. Yeah. So rise over run is the slope. Rise over run is the slope. And since we know 2 different points determine a straight line, if we are given 2 points, then we should be able to find the slope of the line, right? So example 9 tells us how. Very important. If we know 2 different points on a straight line, how do we find the slope for the straight line? I'm going to display 2 methods, all right? I'm going to give you 2 methods. The first method is to use the slope formula. M equals y2 minus y1 all over x2 minus x1. All right? And what is m? We use m to represent slope, okay? In this chapter, we use m to represent the slope. And x1, y1 is the first point. x2, y2 is the second point. Those 2 points are different. They are on the line. Okay? Then the slope of the line can be found by using this formula. In the numerator, we use y2 to minus y1. In the denominator, we use x2 to minus x1. So the first method, we use the algebraic method, use the formula to find the slope. Let me show you how. I would first label the 2 points. I'm going to label this one x1, y1, label this one x2, y2. Okay? And I need you to do this when you use this method. I need you to set up the structure of the formula by using parentheses. All right? Okay. So I'm going to color the parentheses in differently. I have blue here, blue here. Okay, knowing that in the yellow parentheses, we have y sub 2. In the green parentheses, we have y sub 1. On the bottom, in the pink parentheses, we have x sub 2. In the blue parentheses, we have x sub 1. All right? Help me out. Which value in the yellow? Yeah, you have to determine, you have to assign x1, y1, x2, y2 first, right? Yeah. What's the value in the yellow? What's gonna be in the yellow? Yeah, y sub 2 is -1. Y sub 2 is -1. Really? I don't think so. Y sub 2 is +1. That's how I label it. Right? Yeah, +1. Ignore, okay, it's fine. Yeah, in the yellow, we have 1. In the green, what do we have? You still agree? Yeah. In the pink, what do we have? In the blue, we should have this. You know, everybody can do that. You don't have to think. You do not need to calculate in this step, okay? Yeah. Just to put 4 values in a correct color, in a correct parentheses. Yeah, basically, in the numerator, you are using this value minus this value. In the denominator, you are using this value minus this value. Yeah, but you don't have to do that. You can use my method, set up the structure, and then put those 4 values in the correct slots. Yeah, you would have to label the points first. x1, y1, x2, y2, right? And then you calculate in the next step. Yeah, and then you calculate the next step. Numerator, the reason I need you to use the parentheses is because if you have negative values, you don't mess up, or you have less chance messing it up. Sign error, you know, is a very common mistake. Numerator, 1 minus 3. You can use your calculator, right? 1 minus 3. Yeah. Denominator, 0 minus -1. Minus -1 is the same with plus +1, right? So it's -2. Do you agree? A faster way, this is a faster way is this, okay? You put the 2 values vertically. It really doesn't matter which one first, which one after. I can put this up on top of this one. Yeah. So to find the slope, you use this number to minus this number. Okay. 1 minus 3, that is 2. Put it in the numerator. To find the denominator, you use this number to minus this number. 0 minus -1. Yeah, if you can do this quickly without making mistake, because minus negative is challenging for some people. Yeah, 0 minus -1 +1 in the denominator. Yeah, that's the fast way. But if you don't feel comfortable or you make a mistake by doing this, use my method. Use my method, you will not make a mistake. Yeah, let me repeat my method. Firstly, you label the 2 points, x1, y1, x2, y2, right? And then you set up the structure. Oops. Do you notice that is the yes, and then you set up the structure, parentheses minus parentheses, all over parentheses minus parentheses, and then you just need to put those 4 values in the correct slots, and then you calculate. All right, so that's the first method. Use the formula. That is the algebraic method. Algebraic method. Now I'm going to show you the second method. Use the graphing method. Graphing method. I'm going to draw the rectangular coordinate system. And then plot the 2 points. So you have to be very kind of like accurate. You need to have a pretty accurate draft. Even it's draft, you need to be as accurate, precise as possible. The first point is 91, 3 is in quadrant 2. 91, 3 is right here. Okay. I'm gonna label it A. Yeah, it doesn't label by the question, but you can do it. And the second point is 0, 1. 0, 91, 3, 0, 1 is right here. Is point B, right? And I'm gonna connect the 2 points. And then I'm going to a little bit off. Let me modify. -3, 91, 3 is right here. It's A. And then we are going to create a triangle. This is how do we create the triangle, okay? You're going to use this line segment AB as the hypotenuse of a right angle triangle. Do you see this black triangle? Do you see the black triangle? Yeah, you can do that, or you can do, let me erase that. You either do that, or the triangle could be this way. Yeah, depends on your preference. Either way is good, okay? Yeah, or this way. It really doesn't matter, okay? Yeah, some of my students they like the other way because they can use the scale, one of the scale. Right, this is a triangle, right angle triangle. Okay, so now we are going to go from A to B. You have to be certain, confirm the direction. You are going from A to B. Tell me what is the rise when you go from A to B, and what's the run when you go from A to B. All right. Tell me what's the rise, what's the run when you go from A to B. From A to B, vertically go down. Do you see that? Vertically you go down from A to B, right? It declines from A to B. Do you agree it declines? Yes or no? Yeah, from A to B vertically go down. Go down how many units? Go down how many units? From A to B. Awesome. Yeah. Since it's go down 2 units, the rise is -2. Negative. All right. And then run horizontally from A to B. Yeah. You go to the right, not go to the left, right? From A to B, you go to the right. How many units? Yeah, +1, because go to the right, 1 unit, so it's +1, right? And rise over run. negative over 1 is -2. So the slope is -2. Slope is -2, right? Yeah, two different methods to find the slope. The second method, the graphing method, is very convenient, I would say, but it has a disadvantage. First disadvantage is if you don't draw a good graph, if your graph is very messy, this method is probably not your method. Also, if the given points are fractions, if the coordinates involve fractions or decimals, this method is not good method. Okay, yeah, if they are integers like this question, all the coordinates are integers, and this method works better. Okay, so we have more. Yeah, we're gonna leave those for Wednesday. Okay, this week you still have a chance to take your exam. Make sure you still know how to make sure you are learning new knowledge and you do not forget chapter 2. All right, guys, and that's for today. I'll see you on Wednesday. Have a good night. Bye-bye.
Bye-bye.
Professor.